yesterday we were introduced to circuits using FET simulations, and in that video I shared with you about voltage, meaning that's the power. We have amperage, which is the flow of electricity, and then we have resistance, which is something that restricts or slows down the flow of electricity. That can be done either through a resistor or anything that's in the circuit that's consuming electricity is going to have some sort of resistance. So that simulation on the computer was really to get you familiar with some of the terms that I'm going to be using today. We are going to be using snap circuits. So before we get started, there's a couple ways that you can go about doing this, but what I want to have you do is you're going to be in pairs. One of you is going to have this instructional video playing on one of your iPads. The other one is going to use their tablet to go into Schoology to view the PDF that has different circuits that we're going to be trying today. I need you to pay very close attention because the exit ticket is actually going to be within the video. I'm going to tell you what I would like for you to do and how you can submit that exit ticket. So first thing that we're going to do is we're going to open up our Snap Circuits kit. Let me open this up this way. And we're going to find a few things in here. So let me spin this around. I'm going to take some things out just for the video's sake. I don't expect you to take the whole tray out, but just so I can get it in my camera, I'm going to do that here. So we have a few items here. This is going to be very, very important because at the end of class, when you're done, I'm going to ask you before you close up your box, I'm going to come around and I'm going to check your kit to make sure everything is put away properly. So all the kits are the same. They all have the same parts. So that way when we come in and use snap circuits again tomorrow, no matter what kit you grab, everything is going to be organized where it needs to go. So this kit right here, we'll talk about at the end of class, but this is where everything goes, and you might notice that all of these items have little labels on them. This is going to be very, very handy. I'm going to set that aside for now. We have two books that we're going to use. Okay. However, I don't particularly like the order in which these projects are in this book, so I've put them in a PDF in order of which projects we're actually going to be doing. So we're going to set those aside for now. If you want to come back to those and use these as you're watching the video, that's fine. But we're not going to go through these through these projects in order. And there are certain things that we're not going to be able to use or play with until later on. Because my goal here mainly is, while it might be fun to hear a buzzer or music or a siren or watch this fan go, I think it's really more important for you to understand what's happening rather than watching it and making sounds and having the fan go. So I'll set these aside. So we have Snap Circuits kit here now. Now what we have mainly in the middle, that's our building board here. Okay, and it's going to be hard to see in the video, but if you angle, maybe I can get it. Let's see here. Maybe you can see it a little bit. We have A through G on the side here. And then we have numbers 1 through 10. Now, that might be hard to see, but I'm going to bring it to your attention because when you're building, there's parts in the circuit that are going to tell you where to build it. Because what I don't want you to do is, let's say, start a project down in this part, and then it's too big, and it goes off the board, and you have to move your entire circuit again. That's no fun. So we have our build board here, and then we have all of these items that we're going to be using. I'm going to set this aside also, because I'm going to put this on the table in order for you to see it. And then we can get into the building of our projects. So let's see here. First thing that I want to discuss. Pause the video, and what I want you to do is I want you to go into the PDF. And in the PDF, it's the first one, but in your book, if you would like to use your book, that's fine too. I just want to make sure that you stay along with me, whether you're watching the PDF or in the book. But in the book, it's going to be on page 5. It's going to be this one here. So what this is telling us is that we never want to short a circuit. So I'll give you a second. Go to either page 5 in the PDF, or I guess it's the first page in the PDF, or it's page 5 in your book. So pause the video right now until you get to that point that you're actually looking at those pages, whether it's in the book or on your partner's screen. That way you can make sense of what I'm trying to explain here on the board. All right, so I'm going to assume that we are there now. And what it says is never short a circuit. And in the top right of that page, it says examples of shorted circuits. I'm not going to do it on the board, but I will show you what the diagram is showing you. So if I were to push this on the board here, we can build this. So now it's connected. Since this is our first day using these, we don't have the batteries put in. So go ahead and put the batteries in. It's important that these go in the right direction. So the positive side, which is the side with this little nub, does not go against the spring. The flat side goes against the spring. Also, if you look at these, we talked about this a little bit yesterday in the video. This is DC current, okay? Direct current. We have a plus and we have a minus, okay? So a positive, and then we have a ground or a return. So this is what we're seeing on the page here. And what it's saying is you never want to do, let's see if I can make this happen here to show you. Create a circuit that returns to itself. I'm not going to actually connect this. But if we were to connect this back to here, there's nothing that is consuming power or creating resistance. When we were doing the tutorials yesterday on FET simulations, if you did something like this, there's actually a flame that showed fire. Now these aren't going to catch on fire. They were kind of built in to resist that from happening. But if you were to do this, let's say in a real circuit, in your house for that matter, and there is nothing consuming electricity, you're going to blow a breaker or a fuse for that matter. So instead, we need to make sure that there is something that is consuming that electricity. And this is okay. We're not returning just wires directly back to the battery. There has to be something that is consuming electricity. Now, what you need to be very, very careful of as we build these, you need to pay very, very close attention to making sure that there is not a shorted circuit. Now, this is not a shorted circuit. But if you look down below the top one, it says examples of shorted circuits. There's a little more elaborate one, and there's a pink set of arrows. Okay. Now, what that's actually showing us is if we had something, let's say, that goes like this. Oh, and let's find another 3 snap wire. Grab this out of my kit. And I were to connect this here. Okay, I'm not actually going to connect it, but let's just pretend that these were touching. This is a shorted circuit. You see there's nothing going down the flow of these wires as returning back to the battery. So even though we have a good circuit here that's actually consuming electricity, this would create a shorted circuit. So it doesn't matter how elaborate it is. We have to be very, very careful that we're following the instructions and we're building these items exactly like they show in the picture. Pull these off. I'm going to set these aside for now. I'll utilize these. So I'm not going to put them away, but at the end of class, we need to make sure that we're putting them back in the container where they need to go. So now what I would like for you to do, if you're following along in your book, is I actually want you to go to Project 1 in your book. It's going to be page 2 of the PDF. Give you a second to do that. Flip to page or Project 1. Find Project 1 in your book. In your book, it's on page 8. So the very first project that we are going to do is we are going to build an electric light and switch. You can see it says there the objective is to show how electricity is turned on and off with a switch. So let's build this one. If you wanted to do it as it shows on the board, you notice there in the picture, it's the top left it says C2. So this is like Battleship. You ever played Battleship? A, B, C, 2. Okay, and then we have D and E. And then we have 2, 3, 4, 5 going across the top. All right? So if you want to follow along, now this one's a smaller one, so this doesn't particularly matter, I suppose, where you're going to put it on the board. But as we get into more elaborate ones that are going to take up the majority of the board that are bigger, it's going to be very, very important that we put these exactly where they are. So just for the sake of practicing doing that, I'm going to put this battery bank, looks like the top left of it is in C4. So A, B, C, 1, 2, 3, 4. C4. So it should be right here. C4. That looks good to me. Now what you're also going to notice is that some of the items in that diagram are stacked. Okay, so what you're going to see is that the lamp socket in that slide switch, because you can see them, they're actually on top. So we need to build from the bottom up. So the next thing that we actually need to add is going to be that number 3 snap wire. This one right here. Okay, this one's going to start in C2. Just going to be here. Great. Battery pack. This is a 3 snap wire here. Now something that I had here, you're going to find this in the top right of your kit. Make sure that you choose the right one. You can see on the diagram it says L1 on the diagram. In this, let me get it close to the camera if I can see it. I'm trying to do this backwards at my computer. Get it to focus. Maybe. All right, so this says L1 right here. So we're going to snap L1 on top, clip, and now we need to find the slide switch, not the button switch. You can see in your diagram it's S1. Slide switch. Okay, so now, when you were doing FET simulations yesterday, we created a circuit. And in the video, I showed you how there was a little switch that actually kind of looked like this, making a connection. So check this out right here. That's actually what's happening inside this. So if I were to slide this and turn this on, our light turns on, off, on. Now, if I were to take this switch out, and I were to put a snap wire, this is a continuous circuit. There's no switch to turn off and on. There's no way to power this on and off. So that's the purpose of a switch. So think of this as very, very similar to how your light switches work in your house. Now in your house, that's alternating current. This is called direct current. Anything with a battery is direct current. And actually, there's some cases where anytime that we use a computer, there's actually something within the power supply that is transferring, I should say that's not the right word, converting alternating current to direct current because your computer boards only recognize direct current. So we turn this off and on. What I'd like for you to do, I want you to take this out. I'm not going to do it in the video. Pause it. I would like for you to take this slide switch out, and I would like for you to replace it with the switch that's called S2. So find the S2 switch, and I want you to put that in this place, and I want you to explore and see what happens. Let's pause the video, replace this. Okay, great. So now what I'm going to assume is that you've done project 1. In the next one, that we're going to move on to. It's actually not project 2, as you see in your book. I had to do project 2 because these are in the PDF. They were on the same page. But we're actually going to jump down to the next page, and we are going to be doing project 7. So go ahead and either turn in your books and find project 7. Your partner should have the PDF on their iPad. So go ahead and go to project 7. So now we need to break this circuit apart a little bit. I'm going to set these aside. I'm going to use some of these again. Okay, put these off to the side here. And in project 7, it looks like my battery bank is on C5. So C5, I'm just going to move this over here. Great. And now what I need to do is I need to find the one that says D1, not D2, D1. And I'm going to put this, looks like here it says F3. Great. And then I'm going to also put my slide switch that I was using. I'm going to put that on the board. Okay, that's going to go here. And we have something that's very, very important called a resistor. And we're going to use R1 as the resistor. So that's going to go here. Now, if you notice on your diagram, right here, it tells us to use the two snap circuits. Let me find those in my kit here. Looks like they're kind of stacked in some of these sections here. So it's hidden under the 5. Oh, and there's some in the middle. I didn't see those at first. All right, so we need to get 4 of these little snaps. All right. Might be a little tricky to dig these out of here. Great. Look at this. So your LED, called an LED, is turned on. I didn't turn my switch off. So now it's off, and now it's on. Great. So now, I guess something to ask is going to be, why do we need a resistor? This seems just like a regular light bulb. It's in fact not a regular light bulb. This is going to be really, really important, so make sure you pay very close attention to what I'm about to say. These lamps right here can recognize current going in either direction, alternating current. So when you put this on the board, it doesn't matter what direction you place this in. In fact, if your LED is not working right now, let me show you a possibility as to why that might be the case. So it's not working right now. Because if you didn't put this in the right direction, you see this arrow? I'm going to put this back and then I'll explain why that arrow is important. Let's put this back here. Cool. There we go. And now it's back on. My hands might have been in the way when I turned it on, but you can see that it's turned on here. You notice that there's a little plus sign right here. So this needs to be on the positive side of the circuit. So if I were to follow it in this direction and go around, you notice on your battery bank, this is the plus side. Look at your battery bank right now, and you can see it, there's a plus. And then you can see it there is a minus. So this is LED. Now the nerdy thing to learn about an LED, as you can see on Project 7, it's called light emitting diode. A light emitting diode. And you see this little arrow. Now, something else on, let's say it's called a schematic. or when you see a wiring diagram, it's going to have this little arrow with a line. That means it's a diode. And that means the electricity can only flow in one direction. So we have a light emitting diode that the electricity has to flow this way. It cannot flow the other direction, which is why, since this is direct current, and the flow of electricity going through the diode is this direction, that's why if we put it the other way, it was stopping it. Because a diode only lets electricity flow one direction. I want to talk about why this is important. So this is actually a resistor, and I talked about this in yesterday's video. And what the resistor does is it resists, or it slows down the flow of electricity slightly. Still lets electricity go through, but it slows it down. Now, if I were to take this resistor out and connect this, in this snap circuit, it's going to be okay. It's not going to actually break the LED. However, they have something built into this in order to prevent that from happening. And so what we have is we have a resistor inside here. But let's pretend it's not there. This resistor right here actually makes this work properly without popping the LED. It won't actually physically pop. It'll just burn it out like a light bulb. On this resistor, this is if you look at it, and you can see it in your diagram, 100, and that little Greek sign is called omega. 100 ohm resistor. So we have a circuit here that's flowing in this direction. We can turn it off, and we can turn it on. But as you noticed, if I turned this around, it wasn't going to work. Something else just to show you. I put this on top here. I'm curious if somebody might be able to tell me why this bulb is not turning on right now. Interesting. Huh, that's interesting. All right, enough with Project 7. What I wanted you to know is that this is called a light-emitting diode, and a diode is a part that electricity can only flow in one direction. So if this is turned around, that's not going to work. That's essentially what's happening in Project 8. So Project 8, if you look at that, you see it says one direction for the LED. That's what it's showing you. So look at those charts on Project 7 and Project 8. And you can see that the diode, the LED, is turned around, and that's why it's not working. So that's an important thing for you to know if your LED isn't working. The next one that we're going to jump to is going to be Project 47. So jump on Project 47 in your book or on your partner's PDF, and let's take this one apart. Let's turn this switch off. All right, and let's see where it wants to put this to start. So the top of this looks like it's in A5. So A5 is up here. 1, 2, 3, 4, 5, and then A. So A5. So as we build this one, I'm going to want you to pause the video. I want you to build this whole circuit as I do it here. Okay, so we're going to build it from the top down. If I get ahead of you, pause the video. Here we go. LED. Put that resistor back in, same resistor. All right, now as I get to this point, what you're going to notice is, get a few more pieces out. Okay, in your diagram, it says there's a number 1 here, and then a number 1 here. And the reason is that way we can connect these circuits here. So let's do that. So now, this project is called This or That. I want you to take a moment, and I want you to play with these switches, and I want you to watch and see what happens. And I want you to think about why this is called This or That. Pause the video, give you a couple seconds, and I want you to just explore this before I explain and talk about how the electricity is flowing through this. All right, so I'm going to assume that you took the time to go ahead and explore this a little bit. But as we push this button, we see the LED is turning on. As I slide the switch, I can see the LED is turning on. Now, if it's turned on, and I push this button, it doesn't really change anything. The LED is just always on. So the reason why this circuit's called This or That, we have the electricity coming out the positive side, and ultimately it needs to get through this diode. Make sure the diode's facing this direction, otherwise it's not going to work at all. We have the resistor here, and we have these, that this circuit can either go through this, the button switch. Let's see, get my finger out of the way so you can watch it. Or that. Now, if this one's always on, the electricity is always flowing through. So allowing electricity to go through this button doesn't really matter with the circuit because it's always already going through that top switch. Pretty neat. Very, very cool. Okay, let's take this one apart. I'm not going to take it all the way apart because we have a similar setup here for project 48, which is your next one. Okay, and let's take these apart. Let's move this around a little bit. So this is going to go here on the bottom. This is your resistor. We have our slide switch here. Great. And our diode has to go this direction. And now we have our push button switch. And let's take our 3-snap. There. Now this one's called This and That. So pause the video here for a few minutes, and I want you to explore what's happening here. So in order for this circuit to work, when it was called This or That, there were two ways for the electricity to flow through the LED. In this case, it's called This and That because both of these switches need to be turned on. Since this switch is off right now, the electricity is flowing and stopping right here. It's not going through this switch. Now if I turn it on, now the electricity is getting to this point in the snap circuit. And pushing this button now allows this LED to turn on. However, if this switch was off and I were to push this button, that's not going to turn on because the flow of electricity is stopping here at this switch. So you have to have this one on so that electricity flows through this switch, but now it's stopping here. And this switch. So this one's called This and That. How the electricity is flowing. Pretty cool. project 49. So go ahead and just look in your book. That's going to be on page 25. It's the next page in your PDF. But project 49 is called Neither This Nor That. So let's build this one. All right, so let's see. This is going to be in A5. Same spot. Yep, A5. And let's build this from the bottom up. So I'm going to start with let's do the diode first. And the diode is in A3. But notice that arrow is pointing down or pointing towards you in the circuit. That's the way the electricity is going to flow. So that makes sense. We have our resistor. Snap that on. And the things that are across the bottom here are going to be on the bottom of the circuit, I should say. So we have to put the push button and then the slide switch. Okay, so we're good so far. Now this part is going to be a little bit confusing. So if you can follow along with me in the video, it might be easier to build this one because there's a few wires that are stacked. 3 snap in first. Let's connect these two with a 2. Let's connect these two with a 2. And then we need to connect here. And we need to connect here. So what we have here in this is that if your switch is turned on and you turn it off, this is really, really interesting. Why this is happening. So if this switch is off, the LED is turning on. But if your if your switch is on, your LED turns off. What I would like for you to do, leave this switch off. Because what you're actually doing, and the reason why this turns off, is because you're actually shorting the circuit. Let's visualize this. We have the flow of electricity that's coming down and around and back to the battery. So we've created a circuit that can come back to the battery without going through the LED. Now, since the flow of electricity says, hey, it's easier to go this way, the path of least resistance, it's going to go this way. It's going to return to the battery and not go through this LED. If I were to turn this off, what's actually happening is it's blocking the flow of electricity this way, and therefore it's forcing it to go through this LED. All right? That's an interesting circuit there. Why don't we do this? This is a good pause time. Okay, so we're at project 49. Pause the video. Give yourself about 2 minutes. Get up, move around. Please don't bug other students right now that are working. Just get up, do a stretch, and then we can get back to building these. So take just a couple minutes. Okay, so now we have a couple more circuits that we're going to do, and then I have your exit ticket. Your exit ticket is going to be very, very important for you to complete. Let me take these apart. All right, so you have a couple more projects here that we're going to be working on. The next one we're going to jump back up in your book. On the PDF, it's the next page. And we are going to look at the flying saucer and what's happening with that one. All right, so we have our battery pack that needs to go on C5. C5 here. There we go. We have a 3-snap. We have a motor that looks like this. And I want you to pay very close attention to what direction this motor is supposed to go, because there's a plus sign on it. And then we have a slide switch. Our slide switch is off. If we turn it on, we have a little motor that spins. Now what we have here is we have a fan. Look at it, it's spinning. Check this out. When I turn this off, there it goes. I got to catch it. Do that again. Off it goes. Whoa! Lost it. So now what's very important about this that you should know is that this is a DC motor, meaning electricity is going through this direction. These are like little engines, okay? Engines that are powered with electricity, those are called motors. Anything that is powered with a gas is going to be a engine. So let me turn this off here. Great. Now I want you to notice what happens if you turn this around. I'm not going to show you this, but I want you to explore what is happening. I'm not going to turn it off for you, but I want you to play around with this. Pause the video and see what's happening. I wonder why it doesn't take off. That's really interesting. So here's your exit ticket. Last activity for class today. I want you to go to Project 9. Project 9 should be the last page in this PDF. Project 9. And I want you to create that circuit. C5. We're already in C5. Okay, C5. Let's do our resistor, which looks like it's going to be in B3. Nope, C3. There we go. Let's put our diode in, make sure it's going the proper direction. Okay, and I don't love that this is kind of hanging out here, but you get the idea. In fact, what I would do, if it were me, see how these will move back and forth? You can take the little one snaps, put them underneath it. Great. So now if I were to take a paper clip, let me find a paper clip here at my desk. Here's one. Let me get a paper clip out here. All right. So this is not, as you see in the diagram, but you'll get the idea. Same paper clip. Okay? If I were to take this paper clip, and I'm not expecting you to do this lesson because I'm not going to give you a paper clip, and you look here, check that out. That's actually completing the circuit. So here is your exit ticket. This is conductive, which means electricity can flow through it. If I had something that wasn't conductive, electricity wouldn't flow through it. So what I want you to do is I want you to take your wires and I want you to snap them on this circuit. Top of the circuit. Okay? Now what you're going to notice, these are called jumper wires. If I were to touch these together, we are now completing the circuit through these wires. I would like for you to go over to the table in the middle of the classroom, and I want you to take a picture of the an item. Let me find it here. I had one here I was going to show you. There it is. an item on the table. Here's an example. I'm not going to have this one on the table. This is a screwdriver. I would like for you to take a picture of this LED lighting up by using the jumper wire on something that's conductive. So the electricity is actually flowing through this screwdriver to turn it on. Pretty neat. So I would like for you, for your exit ticket, to take a picture, both of you, you and your partner, take a picture of you holding the jumper wires on something conductive and the LED is lighting up. Once you have done that, I would like for you to take apart your whole circuit and I want you to put it back into the container. You forgot where things go? Remember this guy right here? This will tell you where all the items go back in your kit. When you're done with that, I need you to raise your hand. I'll come around. I'll check to make sure that your kit is put back together properly. And then you can close up your kit and we can be done for the day. So this was a lot to discuss. And we're going to build a little bit more on this and review some of this stuff with tomorrow's lesson.